Hello everyone. In this video we're going to be solving a homemade exponential equation. We have 3 halves to the power x plus 3 to the power x equals 1, and we're going to be solving for x values. So let's consider this problem from different perspectives. For example, can x be 0? Okay, substitute x equals 0, just guess and check. 0 power will give you 1. 1 plus 1 does not equal 1. It doesn't work. Can x be 1? When x is 1, we get 3 halves plus 3, which is, again, not equal to 3, right? Obviously, this is greater than 3. I mean 1. So this number is greater than 1. That kind of gives us an idea. If x is in a certain interval, then it's not going to work. Or can we log both sides? So some people say, hey, for exponential equations, why don't you just ln both sides, right? If you ln both sides, then you're going to get something like this, right? And that's going to equal ln 1, which is 0. So that's kind of nice. But then what happens to this? Is that equal to ln 3 halves to the power x plus ln 3 to the power x? Are they equal? And that's not always true. So in other words, we can't safely say all the time that ln a plus b is the same as ln a plus ln b. There are certain situations where they are equal for certain values of a and b, and there are infinitely many solutions for this for over real numbers, because this can be written as ln ab. Oops. Then from here we get ab equals a plus b. And that has infinitely many solutions, or if you're looking for integers, then there are finitely many. Anyways, so this is not a general rule, so we can't do that. So lning both sides with sums and differences, unfortunately, does not work. So we have to do something different. And noticing that when we replace x with 0, we got something greater than 1. I want x to be negative, right? Doesn't that make sense? If x is negative, things are going to be flipped. So let's go ahead and flip this thing. I'm going to write it one more time. And then when you flip things, sometimes looking at things like on the flip side is going to give you a better view. So here's what I'm going to do. I'm going to replace x with negative t. Okay, let's see what happens when we do that. So it's going to be 3 halves to the power negative t. Again, that's my effort to flip these things around, because when you have a negative exponent, things are going to be flipped, right? Remember the rule: if you have a to the power negative n, that can be written as 1 over a to the n, or if you have a over b to the power negative n, then that is b over a to the power n. And of course, this can be written as b to the n, a to the n, but that's another story. So the negative exponent is just going to flip it. By the way, when I say negative, that doesn't mean it's a negative number or a quantity. It just has a minus sign in front of it. And obviously, this is true whether n is positive or negative. What happens if n is 0? It's still true. So it's true for all real values of n. So what does the negative t do? It flips, so we get 2 over 3 to the power t. And by the way, t is cool. And the reciprocal of 3 is 1/3 to the power t equals 1. The right-hand side is constant, so that's kind of nice. It doesn't change. But the left-hand side becomes much, much nicer after this. You're going to see. Why is this much nicer? Now, take a look at this. If you don't see what I see, then take a harder look. Think about it. 2/3 plus 1/3. We probably learned this in arithmetic, right? I don't know what grade, 2nd, 3rd, 4th, but this is equal to 1. Wow, that's amazing, isn't it? Okay, not too surprising, but t equals 1 works, because these are two fractions that add up to 1. Think of it as a pizza. Cut 3 slices. I got 2 slices. You have 1 slice, and put it together, a whole pizza. Okay. So what is that supposed to mean? It means t equals 1 works. But we said that x is equal to negative t. So does that mean x is negative 1? Well, let's see. If you think about the original problem, x equals negative 1 is going to work, because 3 halves to the power negative 1 plus 3 to the power negative 1 equals 2/3 plus 1/3, and that's actually equal to 1. So x equals negative 1 works, but is that the only solution? How do we check if there are any other solutions? So let's go ahead and take a look at this t equation one more time. So I have 2/3 to the power t plus 1/3 to the power t equals 1. Again, logging both sides is not going to help, so we have to look at it from a functional perspective. What kind of function are we looking at on the left-hand side? 2/3 is less than 1, so it is a decreasing function. It's exponential but decreasing. So there are basically two kinds of exponential functions. One is the increasing kind, and the other one is the decreasing kind. All right? Obviously, if they are like, you know, b to the power t, then we're talking about b here. If b is between 0 and 1, then our function is decreasing. So two decreasing functions, when you add them, the sum is also a decreasing function. So what do I mean by decreasing functions? Let's go ahead and take a look at this from a functional perspective. Take f of t equals 2/3 to the power t, and then differentiate this function with respect to t. And remember the rule for exponential functions. You just write the same thing and then multiply by the natural log of the base, and then multiply by the derivative of the exponent, which is the chain rule, but the derivative of t with respect to t is 1, because dt over dt equals 1. It's that simple, right? They're the same, so they can kind of cancel out. Okay, so we don't need to multiply by the derivative of the inside. That's it. Now notice that this quantity cannot be negative. It can't even be 0 unless t is approaching infinity, and that's the limit, right? So we're going to be looking at the constant, ln 2/3. So if you think about the ln function, hopefully you know what the graph looks like. It kind of looks like this. Has an x-intercept at 0. So any x value less than 1 and greater than 0, of course it has to be for the domain purposes, you're going to get a negative y value. So in other words, ln 2/3 is negative. Okay, this is a negative quantity. When I multiply it by a positive quantity, the result is less than 0. If f prime is negative, then f is decreasing. Now a lot of times this comes up, and why do you think that's the case? So think about it, like f prime t is the slope of tangent, right, at point t, or in general. If the slopes of tangents are all negative, so you have a curve that is going up like this, and you draw the slopes, and they all have positive slopes. But if you have a function that is decreasing, and you draw the slopes at different points, I mean you draw the tangents, all the tangents are going to have a negative slope. So negative slope of tangent means the function is decreasing on that interval. Make sense? I know I kept a short story very long, but the main idea behind this is a decreasing function and equal to a constant. Therefore, there should be a single intersection point, and that is going to be at t equals 1, which means x equals -1 would be the only solution. Let's go ahead and take a look at the graph, and we'll just finish up. Here you go. Our function, obviously this is an increasing function, and that's also true for increasing functions, but I wanted to look at it from a decreasing perspective. But again, they're going to intersect at a single point, and in this case, x equals -1. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Correction, I'll see you next time in an hour with another video. And today is the first day. I think we're having 3 videos on Saturday, and from now on I'll try to do 3 on Saturday, 3 on Sunday, you know, just for fun. I'll have a lot of problems to share with you anyways. Be safe, take care, and until next time, bye-bye.